And for some analysis, we're joined by a panel of experts who will give us their views on the impact of Japan's triple tragedy. And structural consultant Dr. Hossein, Rezai, he's the managing director at Web Structures Private Limited. I'm going to start with Hossein. We've seen the extent of the damage that these natural disasters can inflict on infrastructure. How has the increasing occurrence of such disasters influenced the way buildings are designed?
We've learned a tremendous amount from the experience of the Fukushima earthquake. Since the actual event back in March 2011, there are records of about 30,000 more earthquakes happening in the same area of varying degrees. So each of these earthquakes obviously add to our knowledge and information about how these things work. We know the mechanisms involved in earthquakes is basically the ground below our buildings shaking. So the source of the movement is below ground. The way we've designed traditionally for these have been either to allow our buildings to move with the ground and be flexible, or to isolate the buildings from the ground by providing springs and other methods so that the ground below our buildings shake but the buildings do not. These obviously we'll be continuously developing these methods and learning more and more from each and every one of these events.
Structural safety of the buildings. Now, Hossein, have structural engineers actually determined the best shape for buildings to better withstand seismic activity?
Yes, we have. There are quite a number of textbooks on sort of seismic design of buildings against seismic activities, which determine the best shape, the best form, the best height, and the best other things to do with the structural safety. For instance, in longer buildings, very long floor plates are not ideal for seismic-prone areas. So what we tend to do is to break a long floor plate into two smaller floor plates and put a joint in between them, which we call the seismic joint. In terms of height of the building as well, it is not a very good idea to have floor plates which change in terms of size from one floor to another. So the changes ideally need to be more gentle and transition from one floor to another. This is at a textbook level. We've always known that for a long time. What we are trying to do, obviously, is to try and raise the bar and try and ensure that we can, to a large extent, have any shape or any form buildings that we want anywhere in the world, with the knowledge that obviously seismic hazards are different in different parts of the world. And for that, we are using the sort of cutting-edge technologies, new methods of dealing with the ground tremors, which is the main source of the problem with structures, new materials as well, and so on and so forth.
I have a similar question about the tsunami walls, but do you think perhaps we should see higher tsunami walls to protect buildings like the nuclear plants? Can they be better designed and higher to withstand the tsunamis?
Yes, I think we should. I think we should, and we definitely have the technical competence to do that. A wall against impact of tsunami to a structural engineer is very similar to a dam. We are building dams which are much taller than 20 meters and hold the pressure of water all over the world. So there's no reason why we shouldn't be able to do that and integrate a dam-like structure around our nuclear power stations and other buildings of sort of critical importance, the mission-critical ones that need to be operating and working in the event of future tsunamis and earthquakes. I suppose the challenge is to try and incorporate such walls and such measures within the building structure of a power station, for instance, so that it doesn't look like perhaps a sore thumb standing separate. And the main consideration really here is not technical, because technically we can do it. It is economic and to some extent political. We need to have the political will to want to do it and the money to be able to do it. And technically we can design it and technically it can be built. Yes.
Hossein, we know that Japan is very well prepared for earthquakes and their buildings take into account earthquakes. But how can it better build structures to limit the damage?
But there is still a long way to go. It is true, as Adam said as well, and it is sort of a well-known fact that Japan is at the forefront of designing earthquake-proof buildings and structures. When you compare the Fukushima earthquake, which was a 9 Richter magnitude, and it happened about 30 kilometers below the surface of the planet, with the 2004 Boxing Day earthquake in Sunda Trench, which was 9.1, approximately the same Richter scale, happening at about 30 kilometers below ground. Basically identical things. You see the amount of destruction from the actual earthquake are not comparable at all. In Japan, almost not a single fatal accident happened due to the earthquake. All the fatalities were due to the ensuing tsunami. So the buildings were pretty well designed, pretty well built, and withstood the test of earthquake.
So you actually have an animation that you brought with us. Maybe we can take a look at that, and you can tell us in relation to that animation how the buildings are now being built.
Okay.
Yeah.
Okay.
So
the animation shows a building, sort of three towers of 30 stories each, under the effect of earthquake. The motions are sort of exaggerated so that we can see the movements, and it basically shows how the buildings move laterally due to the effect of the ground below the buildings shaking. The design here is not to isolate the buildings from the ground. We've adopted the option of allowing the buildings to be flexible enough for them not to be too fragile and collapse under the effect of the shaking ground. And you can see that the buildings are responding pretty well. The movements are within the limits that the building structure can accommodate, and the earthquake can be a passing event. It happens, the buildings move and shake, and then the buildings come back to a steady state and continue. It's like a passing wind blowing on the building.
I have a question. How about the materials? Are there particular kinds of materials that are good to withstand earthquakes? Or?
There are materials which are best suited to earthquake resistance. The general understanding is obviously lighter materials are better, but that is perhaps possibly a sort of defeatist attitude, in that we accept that the building collapses, let the people on whom the buildings collapse have lighter materials falling on them. But obviously, lighter materials are better, but it is more the actual design and considerations of how the buildings move and how these materials react to the ground motions, which are more determining than the actual materials. As I mentioned, like after the Fukushima earthquake, in the past year there have been about 30,000 other earthquakes in that area recorded. There are different magnitudes. What tends to happen? Earthquakes are not single events. They're part of a much larger process. We call them aftershocks. So they tend to happen. The two tectonic plates adjacent to one another are pushing against one another, and that goes on for some time. There are certain events in it which are of higher intensity, and then we get to know them as particular earthquakes. So once one of them comes to light, there is a series of them also happens. But I don't think we should take this as the occurrence of earthquakes all over the world has increased or has decreased. I don't think they have moved in total sense, but locally around certain clusters, as Adam said, the activities tend to go on for months and sometimes for years. But in overall, I don't think our Earth is getting any more dangerous vis-à-vis earthquakes than it has ever been.